Welcome to MooMooMath and Science Study Guide on Earth Science. Remember, you have a study guide and answer key for each video. Print the study guide out, watch the video, fill it out if you can. Then you can check your answers, and then you have an easy way to study for tests and quizzes. So let's get started with the video. In ancient times, sailors realized that certain winds are always present at certain locations on Earth. In fact, many sailors became rich by using the trade winds to travel from one city to another. Why do we have these winds on Earth? Welcome to MooMooMath and Science and Global Winds. In order to understand global winds, we need to learn some basic facts. Due to how the Earth tilts on its axis, the sun's rays strike the Earth at different angles. This results in unequal heating of the Earth's surface. For example, the equator receives more direct sunlight than places such as the Arctic Pole. This is why the equatorial region is so much warmer than the Arctic and Antarctic poles. Cold air is denser than warm air. It sinks, creating high-pressure areas. Warm air is less dense and rises, creating low-pressure pockets. Air will always flow from high-pressure areas to low-pressure areas. Because the Earth spins, anything that floats above the Earth's surface, such as air, appears to follow a curved pattern of movement. This is called the Coriolis effect. The Coriolis effect heavily impacts the travel pattern of global winds. In the northern hemisphere, air moving from north to south deflects to the left. From the equator to the poles, air deflects to the right. Now let's put all this together and look at some global winds. First, we will label the Earth. The direction of the global winds change every 30 degrees on Earth. You can see I have the Earth labeled 90, 60, 30, and 0 degrees in the northern and southern hemisphere. At 90 degrees, the air is very cold and dense and creates a high-pressure system. At 60 degrees, the air is warmer, resulting in a low-pressure system. At 30 degrees, the air is cooler than it is at the equator, creating a high-pressure system. It is very hot at the equator, and the warm air creates a low-pressure area once again. Notice the alternation between high-pressure and low-pressure areas. Every 30 degrees witnesses a pressure change. Next, remember that the Coriolis effect heavily impacts airflow. Wind systems will twist clockwise or counterclockwise under the Coriolis effect. In fact, this is what happens with the prevailing winds. There are three main prevailing belts: the prevailing westerlies, the trade winds, and the polar easterlies. The polar easterlies are the dominant winds found between 60 degrees of latitude and the poles of the Earth. Remember that air likes to move from high-pressure areas to low-pressure areas. So the wind will start from the poles at 90 degrees, areas of high pressure, and move down towards 60 degrees where the pressure is low. The prevailing westerlies are the dominant winds found between 30 and 60 degrees of latitude, and the Coriolis effect moves them from west to east. Hint: winds are always named from the direction that they start from. The trade winds will move from the high-pressure area of 30 degrees towards the equator, which has low pressure, also called the tropical easterlies because they blow from east to west. Are there areas with little wind? The doldrums, also called the intertropical convergence zone, are such a place. At the equator, the air is very warm due to direct heating from the sun. Remember, hot air rises, and since the equator receives such intense sunlight, the air at the equator rises vertically like a hot air balloon instead of blowing horizontally. As a result, the doldrums, which are located between 0 degrees and 5 degrees of latitude, experience very little wind. The horse latitudes are located at 30 degrees north and south, also experience little wind. The horse latitudes are areas of high pressure, and thus winds go separate ways from one another, searching for pockets of low pressure. The prevailing westerlies will head towards 60 degrees of latitude, while the trade winds will head towards the equators. Sailors have tried to avoid areas like the doldrums and the horse latitudes because they wanted strong winds that would push their boat along. If you'd like to know more about global winds, this playlist will help. Thanks for watching, and MooMooMath uploads a new math and science video every day. Please subscribe and share.